Rare earth elements are considered by some to be critical minerals for economic development in the 21st century and beyond. Several rare earth elements have been identified in old mine dumps above Sheep Creek, Montana. Cerium, lanthanum, neodymium, praseodymium, and yttrium have been collected, assessed, and thoroughly described. Sheep Creek is considered the best current ground truth locale in Montana and is adjacent to known occurrences in Lemhi County, Idaho. The challenge of assessing whether the Hyperion hyperspectral tool can sense the mine dumps and/or outcrops where their samples were recovered is substantial. One of the goals of conducting this remote sensing rare earth exploration at Sheep Creek is to encourage future involvement of the students, faculty, and facilities of a unique nearby mining school, Montana Technological University. Ground truth and satellite images at rare earth mines at Mountain Pass in California and Bayan Obo in Inner Mongolia, China, will be compared to Sheep Creek. Outcrops are sparse at Sheep Creek, and hyperspectral 30-meter Hyperion E01 imaging from 2000 to 2017 may not penetrate pine and deciduous forest and thick soil horizons. More methodology will be discussed when we look at the false color images. Carbonatites are igneous rocks known to often have rare earth elements. At Sheep Creek, these were documented, mapped, and cross-sectioned by Crowley in 1960. Berg mapped structure and stratigraphy in 1977. In 2019, Gammons sampled Sheep Creek upper and lower mine dumps from abandoned adits and quantified average compositions for at least 10 minerals, including 4 rare earth rich minerals, using SEM. According to Gammons, the white tan portion of the rock sample pictured is calcite, dolomite, barite, and the black minerals include allanite, columbite, aconite, rutile, and are niobium rich. References are on the slides after the conclusions. Sheep Creek, Montana is in southwest Montana near the Idaho border. Mountain Pass Mine in California is in southeastern California, between Los Angeles and Las Vegas, Nevada. Bayan Obo is in northeast China. Neodymium and praseodymium are actively being extracted from Mountain Pass and Bayan Obo. These two well-known rare earth producing areas will be examined via satellite imagery to observe if ground truth can be confirmed. The photo at lower left is taken from the ridge looking down and east towards Sheep Creek. The photo at upper right depicts the steep, soil-covered, and in some places, tree-covered slopes where the Sheep Creek carbonatite exposures are mapped by Berg. I see what I think is a tailings pile and a man-made path on the hillside. A digital elevation model from the Montana Bureau of Mines and Geology and rivers and roads from the Ravalli County GIS department are mapping tools made available. The southernmost Bitterroot Valley is beautiful, remote, subalpine national forest land. Since the 1940s, there have been documented strategic rare earth element accumulations around Sheep Creek. The lack of rock exposure and the related lack of data may leave room for a wide range of reserve estimates. In response to a rare earth commodity price spike in 2012, exploration tracts at Sheep Creek and nearby in Idaho were staked for development. The Hyperion false color satellite image extends from Painted Rock State Park in Montana to Duncan's Outpost on the Salmon River in Idaho. Duncan's Outpost is in a region with areas of relatively less vegetation than at Sheep Creek. The Duncan's Outpost area will be inspected in fall 2021. The USGS Earth Explorer website provided access to this free open source imagery. The imagery is terrain corrected, level 1 GST format with less than 10% cloud cover. The Montana, California, and China data all have the same highest quality level of processing. Pre-processing involved first creating a layer stack of 220 images, each with roughly 10 nanometer bandwidth, via the 2016 Imagine software's model maker. Second, doing target detection for each of the 6 mineral targets, including band analysis and elimination. Oxides of rare earth elements are the available targets in the USGS spectral library in Imagine, rather than the elements themselves. To save time, I eliminate the word oxide from the rest of this discussion. The first step of creating the model, using the older model maker rather than the spatial model editor, took me several days for each of Sheep Creek, Mountain Pass, and Bayan Obo. The second step is a roughly 65-step process which takes less than 5 minutes per model in the software. I'm happy to provide the write-up for these procedures. To my knowledge, the vivid false colors of the Sheep Creek image do not correlate well with outcrops. I attribute this to the vegetation and soil cover, not to the complex surface geology. By contrast, as we will see and discuss, Mountain Pass and Bayan Obo, also with complex geologic outcrops, have great correlation between false color imagery and outcrops. The long, narrow strips are the Hyperion sensor format for recording hyperspectral data, which was acquired roughly 400 miles high on the Earth Observing 1 satellite platform. This Sheep Creek imagery was acquired in 2011. The EO1 satellite was in service from 2000 to 2017. Roughly 5 miles wide by 60 miles long, the squares are Montana 6-mile by 6-mile townships. The color scheme will be the same for the next 2 slides, but the regions of inspection will be Mountain Pass, California, and Bayan Obo, China. It is remarkable to observe that these light, rare earth elements show up at all. Published attempts at mapping of Hyperion-sensed light rare earths in peer-reviewed literature over the past 20 years were difficult for me to find. In this slide, Neodymium, Samarium, and Europium have identical pixel distribution. Sheep Creek pixel distribution is very diffuse by comparison to Mountain Pass. Yet, all of the rare earths are far more widely distributed at Sheep Creek than at Bayan Obo. Praseodymium on the left is distributed similar to the previous 3 minerals, but pixel density is much greater in the Montana-Idaho border region. Allanite on the far right shows an opposite pixel density pattern to the previous 4 minerals. Monazite pixel density appears like what I hoped for, and it often overlays Ogden gneiss and amphibolite outcrops from published outcrop maps. In light of the ground truth that we will see in slide 9 in the close-up at the Bayan Obo pit mines, the pixel distribution in the 6 maps on this slide may have significant qualitative value for real-world distribution of light rare earth elements and their host minerals at Sheep Creek, Montana. Mountain Pass Mine in California is where the red dot is on all the maps, except the black dot on the Neodymium map. Mountain Pass is an 84-acre open pit mine which produces neodymium and praseodymium. We will take a close look at the mine in slide 11. The surface geology is, of course, unique and different from Sheep Creek, but the pixel density, by comparison to Sheep Creek, is much higher for each mineral. I see 2 groups of rare earth elements here. Praseodymium and Neodymium, as well as alunite, correlate almost identically, except for one interesting alluvial fan east of Table Mountain. Samarium and europium, as well as monazite, are also distributed very similar. Bayan Obo mines, also signified with the circle, are roughly 300 acres each in size, as we will see when we look closely at the mines in slide 9. Neodymium and praseodymium are byproducts being produced in much smaller volumes than the rich iron ore reserve. But these two rare earths are produced at Bayan Obo in much larger volumes than in other world mines. Using the same processing parameters, praseodymium and neodymium pixel density throughout these images is very sparse by comparison to the mountain pass region. It creates the appearance that the mountain pass area is much richer in neodymium and praseodymium than the Bayan Obo region. This may be grossly misleading. For now, I observe that two different kinds of groups exist. All of the rare earth elements appear similarly distributed, with samarium and europium more amplified, but still correlating perfectly in position with praseodymium and neodymium. Two of the common rare earth host minerals, monazite and alunite, also appear very similar. That will change when we look closely at the Bayan Obo mines. Another presentation deserves to focus on the position of the Bayan Obo mines on the southeast flank of a dramatic, east-plunging anticlinorium and all the development targets, or what I would call step-out targets, along strike, as well as on the northeast limb. These step-outs affect reserve estimates. If I were just to use these regional, distant satellite images to compare neodymium abundance at Sheep Creek, Mountain Pass, and Bayan Obo, I would observe two obvious things. First, neodymium pixel density appears far greater and more widespread at Mountain Pass than at Bayan Obo. This compels me to that potentially dubious conclusion. The Mountain Pass area is richer in neodymium than the Bayan Obo region. Second, I noticed that Sheep Creek looks very diffuse by comparison to Mountain Pass, and yet more pervasive than at Bayan Obo. 8 old mines at Sheep Creek, which we will view more closely in slide 13, may be strategically located. They may be in the northern portion of a central region extending into Idaho, which is relatively rich in neodymium. These 2011 images show the Bayan Obo east and west mines. They are roughly 344 acres and 247 acres, respectively. The background is a false color image with the same red, green, blue mix of bands 194, 92, and 29 used at Sheep Creek and Mountain Pass. The foreground in white and pinkish white is the distribution of each of the 4 rare earth minerals and the 2 host minerals in the mines. Each pixel in the image is 30 meters by 30 meters in size. At this close view, the groups look different than far away. Praseodymium and neodymium, monazite and alunite clearly correlate and extend into the mines. Samarium and europium only appear on the north rim of the mines. This looks like ground truth to me. Drew, Kingrun, and Weijun in 1990 is an early paper which details the structural geology of the region. The Hyperion data illuminates features of the immense east-southeast plunging complex anticline Bayan Obo is on this anticline's southeast dipping south flank. Mountain Pass Mine is very obscure at the distant image, in between and up close. The red circle identifies it here. The L1 GST images are 2002 vintage. The false color image here correlates very well with outcrops. The false color image at left shows stratigraphy at the Mescal Range and striped mountain brightly. The target detection identifies neodymium oxide throughout the Precambrian, Cambrian, Devonian, and Carboniferous sequences. The outcrop map and false color image show the complex geology well. Neodymium in the Clark Mountain Range is very distinct. At least 4 other prominent features, which deserve more research, include Devil Peak and the alluvial fan to its east, and Table Mountain and the alluvial fan to its southeast. Here at Mountain Pass, the 84-acre mine is hard to see. A closer look gets even fuzzier. The red square outlines the mine. Praseodymium and neodymium and alunite correlate in distribution. Europium and monazite are similar. There is uniqueness to samarium distribution, as it is more pervasive within the mine. Monazite is mostly absent from the mine. Bayan Obo close-ups of the hyperspectral imagery are still the most compelling evidence that Hyperion can correlate precisely with rare earth ground truth. Transon in 2018 details space-borne hyperspectral sensors, which are in the process of becoming operational, beyond the now retired Hyperion and other hyperspectral sensors. Image files will eventually be less long and narrow and will be far more useful as a result. Sheep Creek looks noisy close up. The bare north slope of Beaver Creek, west of Sheep Creek, is absence of praseodymium and solid with monazite. The north slope of Sheep Creek, where 6 of the 9 old mines were, has some narrow vertical stripes of monazite which may prove meaningful. Also, almost the entire image, including the north slope of Sheep Creek, is solid with praseodymium. Up close there is a diffuse pattern of neodymium, samarium, and europium. Maybe thick soil and pine forest affect this. The numbers 0 through 8 beside the yellow dots are the positions of old mines around Sheep Creek. All of the previous images have been threshold 1 images, with the most dense possible distribution of all minerals. Threshold 6 shows neodymium oxide no closer to any of the 9 former mines than 1,320 feet or 400 meters. I hope that ground truth can be matched to this Hyperion satellite sensor with more confidence in the future. I do not yet know which, if any, of the images is more useful for assessment. Qualitative Sheep Creek assessment by comparison to producing mines at Bayon Obo and Mountain Pass may suggest widespread presence of oxides of 4 light rare earth elements in southwest Montana in the Lemhi Pass area. No quantitative assessment in terms of ore richness or neodymium oxide parts per million, for example, has been accomplished. Where L1 GST Hyperion hyperspectral data is available near Mountain Pass, California, strong quantitative assessment appears possible via ongoing ground truth correlation. Bayan Obo mines exhibit extraordinary ground truth for all 6 target minerals from the Hyperion sensor. Adjustment of geoscience research toward rare earth minerals for those transitioning away from other energy minerals may be rewarding and fun.